Have you ever really stopped to think about what goes into good research? I mean, whether you're trying to learn something totally new or maybe get ready for a big meeting or just understand the world a bit better. It really all comes down to finding the right stuff, the right information, and then, putting it all together. And right at the heart of that whole process is search, isn't it? But how does something like an AI, specifically these large language models we hear so much about, how do they handle this? This very human thing of looking for knowledge. So today we're going a deep dive into this really fascinating world of AI search agents. We're going to pull back the curtain a bit, look at how these AI models actually manage to find information, what kind of challenges they face, and some are pretty surprising, maybe frustrating even. And then the really interesting part, a brand new protocol that's honestly changing the game for how they learn and connect with data that's outside of themselves.
Yeah, and our mission today, it's pretty straightforward, really. We want to demystify some of these, let's say, more complex ideas around how LMs get hold of and actually use external data. We want you to walk away with a good grasp of, the cutting edge of AI research, but without getting totally lost in the technical weeds. And everything we're discussing, it comes from a really detailed, solid explanation of this tech. So you're getting the real story straight from the source, as it were.
Okay, so let's unpack that. Think about how you do research. You usually start with an objective, right? What exactly are you trying to figure out? What question needs answering? Then you make a plan. Like, okay, I'll check this source first, then maybe look at that website. You go out, you gather the info, searching here and there, maybe the web, maybe internal company files. And as you find stuff, you start refining things, yeah? Maybe even change your plan based on what you discover. And then finally, you pull it all together and generate your answer. This is kind of natural cycle. Discovery, refinement, answer.
And what's really fascinating, truly, is how these modern AI systems, especially what we call multi-agentic systems.
Multi-agentic, so like different AIs working together.
Exactly. Different specialized AI parts or agents collaborating on a bigger task. They are literally designed to copy that human process you just described. They follow that same loop.
Yeah.
Define, plan, gather, refine, respond. And like you said, search isn't just bolted on, it's fundamental, it's core to the whole thing. Which means how search gets implemented in these systems, well, it's not just important, it's absolutely critical. It determines if they can actually work properly and reliably.
Okay, but here's the bit that kind of blows my mind, and maybe feels a bit wrong at first. By themselves, these big language models, they actually can't search the real world. It's a huge blind spot. Really surprising given how well they can chat, right? They aren't just automatically plugged into the internet. They don't have like a direct line to live databases or search APIs. They just lack that ability we take for granted, grabbing real-time info on demand. It's like having a librarian who's read every book ever printed but is locked inside the library. Can't get anything new.
Right. And that limitation, that inherent gap, leads us straight to this idea of tool calling. It was kind of the first big solution to that blind spot. Tool calling is basically the process where the LLM, since it can't search itself, asks an external service or capability to do it instead.
Oh, okay. So it's like asking for help.
Precisely, like a smart assistant knowing who to call for what. If the LLM needs, say, current web results or needs to check a specific database or use some other external API, it calls a tool. An application or maybe a framework someone built exposes these external things as defined tools. Each one have a name, a clear description of its job, and exactly what input it needs to work.
Gotcha. So the mechanics are pretty smart then. The LLM gets a query, figures out it needs outside help, maybe for today's news or a stock price.
Yep.
It doesn't guess. It puts together a message saying, I need tool X, like web search tool, and maybe gives it the search query. This message goes to some kind of middleman application.
Exactly. That application acts as the dispatcher. It takes the LLM's request, formats it correctly for the actual external service, and sends it off. Then that service, the search engine, the database, does its thing, finds the data, sends it back to the dispatcher app.
Which then passes it back to the LLM.
Right. So now the LLM has fresh, real-world data, and then it formulates its answer based on that.
So instead of just making something up, potentially hallucinating, it can say, okay, based on this recent data I just got, here's the answer.
Exactly. Here's what I found from these sources. It's grounded in actual external info.
Wow.
And yeah, this tool calling approach, it's super common now. Lots of open source tools help developers set this up.
Okay, that makes sense. It sounds like a necessary step.
It was absolutely foundational, pushed AI forward a lot, but it's definitely not perfect. It comes with some pretty significant headaches, actually.
Okay, like what are the hurdles?
Well, despite how useful it is, developers and data scientists using this, they run into a couple of big ones pretty consistently.
Right. The first one you often hear about with LLMs generally is hallucination. How does that play out here with tool calling?
It can be really frustrating. The LLM gets a request, tries to figure out which tool to call,
Yeah.
and it might just make up a tool name.
Like invent one on the spot.
Yeah, just fabricate a name that sounds right, perhaps, but doesn't actually correspond to any real tool defined in the application.
And if the tool doesn't exist?
Then nothing happens. No data comes back. It's like asking your assistant to use the, I don't know, the Quantum Widget Finder 5000. Sounds impressive, maybe,
Yeah.
but it's not real, so dead end.
Okay, that's one issue. Making up tools.
Then, building on that, the second big problem isn't just inventing tools, it's poor selection. Picking the wrong real tool.
So the tool exists, but the LLM messes up choosing it.
Exactly. And this can happen for a couple of reasons. Sometimes, frankly, it's just a limitation of the LLM itself. Some models are just better than others at this function calling thing.
Function calling being its skill at picking and using tools.
Right. Its ability to understand the user's real goal and match it to the best available tool. So a less capable model might just default to a general web search when the answer was actually sitting in a specific internal database it could have used. More efficient, more accurate perhaps. But here's the tricky part. Sometimes it's not even the LLM's fault directly.
So
Imagine you're the developer setting this up, and maybe you've defined multiple very similar tools, like 2 different databases with slightly overlapping data, or maybe multiple search APIs.
right.
Even a really smart LLM could get confused if the descriptions you wrote for those tools are too similar, too ambiguous. It might just accidentally pick the wrong one, and boom, you get incorrect or irrelevant data back.
Right. So the way the tools are presented to the LLM matters a lot,
The
too.
huge amount. Garbage in, garbage out, potentially.
Okay. Hallucination, poor selection. What else?
The third big one, maybe more from the developer or data scientist's viewpoint, is just the complexity, the sheer maintenance headache. Yeah, I can see that coming.
You, as the developer, you have to build and maintain this whole intermediary application, defining all these tools, keeping track of them.
And what if the external service changes? Like, the database updates its API?
Exactly. That's the nightmare scenario. Some third-party service you rely on changes how its API works, maybe introduces a new authentication method, changes the data format.
And suddenly your tool definition inside your application is broken.
Instantly broken. And if that tool is crucial, your whole AI agent might just stop working correctly.
Ouch.
Yeah. It creates this massive burden of app maintenance. You're constantly having to watch for external changes, update your tool definitions, test everything again. It really slows down innovation. Just keeping things running becomes a major job.
Okay, so tool calling. Necessary first step, but prone to errors, tricky to manage. Seems like there has to be a better way.
And there is, or at least a much more elegant way is emerging. This is where the Model Context Protocol, or MCP, comes in.
MCP. Think of MCP not just as software, but as a kind of standardized connector, a universal plug for LLMs.
Like that, how REST APIs became the standard for web services.
That's a great analogy, exactly like that. REST gave us a consistent, predictable way to talk to all sorts of web services. MCP aims to do the same thing for AI models needing to connect to external tools and knowledge sources. It's about creating a common language, a standard interface, so the LLM in the outside world can communicate much more reliably and easily.
Okay, interesting. How does it work then? What's the architecture look like?
It's actually quite neat in its design. You basically have 2 main parts. There's an MCP client. This is that your LLM talks to directly. It's like the LLM's personal agent for dealing with the outside world via MCP.
Okay, the client talks to the LLM.
Right. And then there's an MCP server. This server is the component that actually connects directly to the external services, the databases, the APIs, the web search engines, whatever.
Client talks to LLM, server talks to the tools.
You got it. But here, and this is the really clever, pivotal part, the MCP server, the piece that handles the messy details of talking to the actual external service. That server is managed by the service provider themselves.
Wait, so the people who run the database or the API, they manage the MCP server part?
Precisely. This is the key simplification. The AI developer, the person building the agent, they don't need to worry anymore about the specific, constantly changing details of how to talk to that external database API.
Because the database provider handles it.
Yes. The provider, who knows their own service best, they manage the MCP server that exposes their service in a standardized MCP format. They keep it up to date. The LLM, through the MCP client, just connects to this ecosystem. It plugs into this standardized, reliable interface. It massively simplifies things for the AI developer, takes a huge chunk of complexity off their plate.
Wow. Okay, that does sound like a big deal. So the benefits, the first one
Yeah.
seems obvious. A uniform interface, right?
Absolutely. Developers don't need custom code for every single tool anymore. MCP offers one standard way to connect to potentially hundreds or thousands of different services.
That's huge for scaling up and just moving faster. Build one MCP integration and you can connect to lots of things.
Exactly. Which leads to the second benefit. It makes connecting plug and play.
Like USB-C. Connect to anything.
Yeah, that analogy works well again. Just like USB-C lets you connect lots of different devices with one standard port, MCP lets AI models connect seamlessly to various services. They can even potentially switch between different providers offering similar tools without a major reconfiguration.
How does it know what's available? Does the client just guess?
No, there's a clever mechanism built into the protocol. It's called reflection. Essentially, the MCP client can ask the MCP server, hey, what tools do you have available? How do they work? What information do they need?
Ah, so it discovers the tools dynamically.
In real time. It's like asking the librarian for the catalog and instructions instead of just wandering the shelves hoping to find the right book. Much more efficient and reliable.
Okay, uniform interface, plug and play. And I guess this all leads to better reliability, more trustworthiness.
That's perhaps the most crucial benefit. Because MCP provides this clear, standardized way for the client and server to communicate about available tools, the LLM is far less likely to hallucinate tool names.
Makes sense. The client knows exactly what tools are available from the server.
Right, and it's also less likely to pick the wrong tool because the reflection process gives it clear information about what each tool does. The definitions are managed by the service providers themselves, who have an incentive to make them clear and accurate.
So it builds a much more stable, reliable bridge between the LLM's brain, so to speak, and the real-world data it needs. Fewer errors, better results.
Precisely.
Yeah.
It dramatically cuts down on those hallucination and poor selection problems we talked about earlier, leading to much more trustworthy AI-driven research.
This MCP approach sounds genuinely transformative then.
It really is. We're seeing the landscape for AI search evolve very quickly, and standardized protocols like MCP are definitely leading that charge. It fundamentally changes the game. It makes integrating external knowledge and tools so much less painful, less burdensome for the people actually building these AI systems. It frees up developers and data scientists to stop wrestling with brittle, custom integrations and focus more on the core AI logic, on building smarter, more capable agents.
And thinking about it from the listener's perspective, for you, whether you're someone who's actually building these systems, maybe optimizing them, or even if you're just using AI tools more and more in your work or life, understanding these kinds of search strategies like MCP, how AI gets its information, that's going to be really key, isn't it? To actually unlocking the full power of AI research. It helps you understand the strengths, maybe the limitations, and ultimately get the best, most accurate information out of these incredibly powerful tools.
Absolutely. And maybe just a final thought to leave you with. Consider this. How much faster, how much more reliably could you gather information for your own projects? Whether that's for work or maybe a personal passion project or just learning something new. Imagine if AI agents could access and pull together knowledge with near perfect accuracy and relevance because of systems like MCP. What does that unlock for you? What new possibilities open up for your own learning, your own problem solving, when getting the right information becomes that much easier and more dependable?
That's a great question to ponder. It really could change how we approach complex tasks. And on that note, we genuinely love to hear your thoughts on this deep dive. What do you think? What implications do you see for the future of AI, for how we find and use information, especially with ideas like MCP coming into play? Please do share your ideas and suggestions. We really value your input, and we're always keen to continue the conversation. And hey, if you found this deep dive interesting or helpful, we'd really appreciate it if you could give it a like, maybe subscribe if you haven't already, and perhaps even share it with others who might find it useful. It helps us keep bringing you these explorations into the latest in AI. Thanks for joining us.